Mr. Chweya and teacher of mathematics. I want to take you through a question in vectors 2. I believe the candidate class will benefit a lot and those who are in Form 3. Now, the question reads, the figure below shows a triangle of vectors in which OSSP is 1 to 3, OSSP is ratio 1:3, PRRQ, ratio PRRQ is 2:1, and T is the midpoint of OR. T is the midpoint of OR, meaning the ratio OTTR is 1:1. Now, part A says, given that OP is vector P, OQ is vector Q, express the following vectors in terms of P and Q. Vector OR. So vector OR, O is our starting point, R is our ending point. So OR will be OQQR, is OQ plus QR. What is OQ? Vector OQ is small q. Vector QR is 1 over the total ratio 3 of the whole vector QP of QP. So what is QP? But QP, vector QP, we are going in that direction, will be given by QOOP. QO plus OP. So QP is QOOP. QO, we are going against the direction of O vector OQ, so it will be minus Q plus OP is vector P. So you can rewrite it as vector P minus vector Q. And then we substitute it here where we have QP. So therefore, OR, vector OR will be, let me write it clearly down here. Vector OR will be Q plus a third of P minus Q. So if we open these brackets, we will have vector Q plus a third P minus a third Q, which is Q. So the like terms together, Q minus a third Q, Q minus a third Q, plus a third P. Q minus a third Q is 2 over 3Q plus 1 over 3P. So this is a vector OR. Then we go to Roman 2. We need to find vector QT. Vector QT. You are starting at Q, you want to end at T. So starting Q, you want to end at T, you can go QRRT, you can go QR plus RT. QR, what is QR? We have the ratios. QR will be 1 over the total ratio 3 of QP, going in that direction. So QR will be 1 over 3 of QP. Have we found QP? QP is here. So we found QP as P minus Q. So this will be P minus Q, then plus RT. Remember, RT, T divides OR into the ratio 1:1. So RT will be 1 over 2. This will be 1 over 2 of, so RT is 1 over 2 of RO. But what is RO? But RO, I believe we had already found OR to be, OR is here. We found it to be 2 over 3Q plus a third P. So if I want to find RO, then I will change these signs. These two are positive, so I'll change them to negatives. So RO will be negative 2 over 3Q minus a third P. So then if I substitute it here, I open this bracket, I get a third P minus a third Q plus a half of RO, which is minus 2 over 3Q minus 1 over 3P. So this one will therefore be a third P minus a third Q. This positive times negative will be a negative, so that will be minus 2 over 6. Minus 2 over 6, which of course will cancel. These two and these two will cancel to get minus 1 over 3. Minus 1 over 3Q. Yes, correct. Then this positive times a negative will also be minus 1 over 6 of P. So like terms together, P and P, and then the Q's together, we shall have a third P minus 1 over 6P, and then minus 1 over 3Q minus 1 over 3Q. So what is a third minus 1 over 6? So this, the LCM between these two will be 6. 3 goes to 6, 2 minus. 6 goes to 6, 1. This is P. Then minus. A third minus a third will be minus 2 over 3 of Q. So this 2 minus 1 will be 1 over 6P minus 2 over 3Q. So this is that is QT. Now part B of the question. Express TS in terms of P and Q, and hence show that the points Q, T, and S are collinear. So can we express TS, vector TS, in terms of P and Q? So T is your starting point, S is your end point. T, S, TS. TS can be given as TO or S. So it is TO plus OS. So what is TO? TO will be a half because T is the midpoint. So TO will be a half of RO. TO is a half of RO. A half of RO. OS is of course 1 over 4 of P plus 1 over 4 of P. This is P. Now, a half of RO, a half. Remember, we had RO is here. This is RO. Minus, so it is a half of minus 2 over 3 of Q. And then minus 1 over 3 of P. Then plus 1 over 4 of P. So if you open this bracket, these two and these two will cancel. You will get minus 1 over 3 of Q. And then a half times a negative a third will be minus 1 over 6 of P. And then plus 1 over 4 of P. So we have these two like terms. We shall have the two like terms. So it will be minus 1 over 3 of Q. These two, if you solve them, you shall have minus the LCM between the two. Or we can rewrite them as plus 1 over 4P and then minus 1 over 6P. So LCM here. So this will be minus 1 over 3Q plus LCM is 12. 4 goes to 12, 3 minus. 6 goes to 12, 2. This is P. So we'll have minus 1 over 3P plus 3 minus 2 is 1 over 12 of P. Sorry, this is Q, sorry. This is Q. This is Q. And this is P. So that is TS. That is TS. Now expressing, express what? Show that Q, T, and S are collinear. So if Q, T, and S are collinear, if Q, T, and S are collinear, then we should be able to express QT, we should express QT as a scalar multiple. K is a scalar here, as a scalar multiple of the whole vector QS. So how do we do that? We must have found QT somewhere. QT, we calculated it and got it to be this one here. This is our QT. QS, have we found QS? We haven't, but it is easy to find. So QT is this one, which is 1/6 of P minus 2/3 of Q. Can we be able to express this as scalar multiple K multiply QS? What is QS? QS is QO or S. QO is negative Q. OS is 1/4 of P plus 1/4 of vector P. So this will be 1/6 of P minus 2/3 of Q is equal to negative KQ. If you open this bracket, K minus times negative Q is negative KQ, then plus 1/4 of KP. So at this point, we need to equate where there is P, you equate with where there is P on the other side. So this will be 1/6P equate to 1/4 KP. So if I eliminate P at this point, I will divide by P by P. So this P will cancel. I remain with 1/6 is equal to 1/4 K. If I find the value of K at this point, I will have a quarter K is equal to 1/6, meaning that K will be 1/6 times 4/1 by 2 by 2/3. The value of K is 2/3. Doing the same on the others, if I also come back here, I equate to where there is Q, equate to where there is Q on this side, I will have negative 2/3 Q, equate it to negative KQ. So, how do I eliminate Q? I divide by Q, divide by Q, this one will cancel. You get negative 2/3 is equal to negative K. So you see negative K means there is a negative 1 behind here. So you divide by -1 all sides. -1, this will cancel. The value of K will still remain positive 2/3. So you see, when the values of K, that is the scalar, remember K is the scalar. When the scalar is the same, then you can come and conclude that since, now we are here, we say since QT, it can now be expressed as 2/3 of QS, and one point must be common, the middle point where we have Q, and Q is a common point, and Q is a common point, comma, points Q, T and S, points Q, T, and S are collinear. Point Q, T, and S are collinear. Good. So up to that point, you should have scored at least 8 marks. 8 marks. Now, I think for part C, let's finish it up tomorrow when we shall review the question again so that we are able to finish part C. But for part A and B, let's leave it there for the sake of time. Thank you, and I wish the best for the candidate class.